video, we're going to look at a very basic introduction into IPv6 for MikroTik. I've not done this before. I've not done a video rather on IPv6 before, so we're going to keep this very high level. We're not going to go into heaps of detail about the technical side of IPv6 because there are numerous videos and information out there about the structure of IPv6, how it came about, the reasons for it, and everything else. But being a MikroTik channel, we're going to look at setting it up, a sort of a basic setup for IPv6. Now, IPv6 can be a bit daunting to some people, which would pretty much run away every time you say you're going to use it. But why would you use IPv6 now? Obviously, the reason for the IPv6 over the IPv4 is the size. So there are thousands upon millions of available IP addresses with v6, whereas with v4, although when it first was brought to the world, was the use case for the internet, I guess, was very small. So we didn't need as many as we thought we were going to need. So at the time, IPv4 was perfectly suitable, whereas now we've obviously outgrown that. So what this does is this gives us a far greater number of IP addresses to use. Effectively, what we get is different types of IP addresses. So we've got what is called the link local, and these are auto-generated, and they're for communication within your network link. So I guess you could imagine that being like in the same subnet almost. They're often generated, they start with this FE80, and they're often generated from the MAC address of the interface itself. And then we have the global Unicast. Now this is similar to public IP addresses in IPv4. They'll often start with a 2 or a 3. And these are the ones we're going to be concentrating on today. Now these are going to be like your main IP addresses for not only for your internet facing interface, but also your internal network as well. And then we have this unique local one, which I guess you could compare to IPv4 private IP ranges, but it kind of works differently because the whole point of, and which I'll get into a bit more detail, the whole point of this is we don't need to have a private and a public subnet. So yeah, we'll look at how you would set this up if you wanted to do it this way, but then I'll explain the reasons you perhaps don't need to if you're going to do a setup like I've got today. Effectively, if you were to run your own internal lab or some testing, or a network that would never need to route over the internet, then you could use this range here, and it starts with FC00. If you're again, I'm not going to go into too much detail about the way that the address is formed, but basically everything's separated by these colons, and if you have basically 4 zeros, then you can get rid of them altogether, and then you just have the double colons, which effectively means that it's like having a /0, or a dot 0 like this. So that would be 10 dots and then blank, if that makes sense. But again, check out lots of other videos about how this is all formed. We're just going to focus on the setup today. But yeah, some key points. The way that I look at it, and this is my own personal way to think about it, is basically you want to forget about NAT. So network address translation, very important in IPv4. So you have your internal network and your external network, and you need to basically NAT your traffic from internal to external. This is no longer needed. Assume that every device has a public IP address. So the way we're going to look at it is if your ISP was to provide you with a /24 of public IP addresses, and then you would assign a public IP address to every single device in your network. And then you wouldn't need the NAT because you can then just route. And then DHCP is not what you think. So DHCP isn't used. It's still used, but it's not used in the way that you would think it would be used for IPv4. And again, we'll get into that. But yeah, I'll try and just give a quick summary of what I was just talking about there. So we've got our internet here. So this is our ISP. That's very thick. Let's get everything on. And what they're going to do, they're going to advertise us what's known as a prefix. A prefix, which is like a subnet, and that can be something like a /56 or 48 or something like that. Now what we do is we then take that prefix and we add it to an interface on here, which will be our LAN. We'll have an IP address in that range, and then we would assign one to each one of our devices. Okay, so as I mentioned, we don't need to NAT. So this device here will have a public routable IPv6 address. So when that routes its traffic, it will go out here into the internet, and whatever it hits on the other side will know how to route back. And this is doing is routing and firewalling. Important. Firewalling becomes very important in this setup. Okay, because what it's effectively doing, you're sticking a public IP address on here that someone over here on a different network, if it knows that IP address, can then just route to. But what you need to control here in your firewall is the access between the two. So what you would have had with IPv4, these would have had an IPv4 address, a private address, which would have existed on this LAN inside this network. This would have had a single public IP address, and then your traffic, let's just go for different color. So your traffic going out would have to then be what's called NATed or masqueraded, as it's known in MikroTik, to whatever the public IP address to be sent out to the internet. So then when this device then wants to route back to it, it's going to route to that public IP address, and then on its NAT table is going to then, a session table is going to know how to send that traffic back. Okay, but they don't need this part anymore. There is something called NAT64, which is a way of basically routing a IPv6 address onto an IPv4 public address. So if your ISP didn't provide you with this prefix, you had no way of routing your IPv6 range to the internet or anywhere else. You could basically NAT it behind a IPv4 public address, but this isn't a feature that's available with MikroTik. You need to use a third-party product for that. So we won't be looking at that today, but we can in future if people feel the need for it. But yeah, so let's jump onto the configuration now. So what I've done, of what I'm going to show you now, is I've put this together, this very high level explanation about what we're looking at, and then basically a guide of what we're going to do. Keeping it very simple today. My setup is basically I have a L009 router, which I've got connected to my network, my internet provider. Then I have the LAN, which is going to be what I'm going to use for testing for my IPv6, which is what my machine that I'm on right now is plugged into. And then I've got this second connection into the same machine, which is running over IPv4. Now that is just so I can have remote access to this machine without playing around with its LAN settings. And in fact, the ISP, I've also got an IPv4 connection on that, so I can get remote access. But you shouldn't need to worry about any of that. We're not going to talk about IPv4, and I'll show you when we actually get the IP address on this machine. As you can see, there's no internet. We're only giving it an IPv6 address, no IPv4 on this network. So we'll show you how we connect purely just on IPv6. So first thing we do is, once we've created our bridge, just a standard LAN bridge, we need to go ahead and on this IPv6 menu, not the normal IP one. As you can see, there's a lot fewer features with IPv6 than there is an IP. That is partly to do with the fact that a lot of what you had to do on IPv4 is not needed on IPv6, but also just the I guess the support for it isn't there at the moment, because it isn't as adopted as it probably should have been or should be. But anyway, that's another topic. So first thing we're going to do is we're going to use a DHCP client. Now, I mentioned DHCP isn't what you think. So DHCPv6 is different to the IPv4 version. Now, the client isn't so much. What we're going to do is we're actually going to grab a prefix. So we're going to get a route from, or a range, a subnet from our ISP. Whereas normally you would set up a client to your ISP and you would get an address, and then you could also get a default route and use the peers, so your ISP's DNS and NTP and stuff like that. This is very similar in that respect, except we're going to get a prefix, which is going to give us a network range that we can use. And basically, the range that it gives us is what the ISP is routing towards us. Now, the way that talks to each other in terms of the way that we route across devices is done on its link local range, but I'll show you that, and I mentioned that at the beginning. But first thing we need to do is select our interface connecting to our ISP, tick the prefix one. We need to just select the name because it's going to generate us a v6 pool, and then the prefix length we're going to create. Now, this is the prefix length that's going to create for the pool itself, not that we're going to be getting from the ISP. So we can just leave that as 64 for now. And then we want to add default route as well. We apply that. Okay, there we go. So it's now giving us a /48. Now, as I mentioned before, these semicolons, this basically means that we've got another 3 sets of 4 zeros here. So what we do, simplest thing, because IPv4, and if you've worked with IPv4 for a long time, you'll pretty much memorize IP addresses, and you can, because there's only 4 octets to think about, so it's pretty simple. Whereas now we're dealing with multiple. So first thing I'm going to do is just give my laptop internet access again, just to show you this. Okay, and then we can jump back on our web browser and we just type IPv6 calculator. I did put a link to one in the into my guide on here as well, which is just this one here, where it was, this one here, site 24 seems to be quite a good one. But yeah, this means that we can then, like you would do in any other IPv4 calculator, it will give you then availability to subdivide your subnet. So this is our block, this is what we've been given, this /48. So if you imagine your ISP may give you like a /29 IPv4, which would give you 6 usable IP addresses. This time it's giving us a /48, which is giving us, well, if we look there, does it tell us? No, this one doesn't actually tell us how many IP addresses, but it's going to be a lot, trust me. So here we can go to, there we go. So within that /48 they're giving us, we can generate, which is the smallest subnet we can go to, is a /64, and that gives us 65,536 subnets, which is more than enough for us, considering we've only actually got one device hanging off it. But that effectively means we can, with that one network, provide a public facing IP address to, that times however many IP addresses are available in a /64, which is thousands. So we're well and truly covered there. So we're going to take the first range, so it's subnetted it up into these /64s. We will just take that first one. Let me jump back on our MikroTik, and then we can close that. Well, now we go into IPv6 addresses. Now we're going to put the IP address onto our LAN bridge. Now this is the subnet, and as I mentioned before, these are actually referring to zeros. Now, any more than 2 zeros together, you can basically knock off. So that's why we've only got 3 here, because there'll be, I believe it's a leading 0. So as there's no zeros here, we can put the basically just 1. So this is basically .1, as you would do for most of your IPv4 addresses. You would often use .1. Just jump back on that website. So it's quite hard to, because it's such a large address. See, that's actually that 1 there is in between those 2 colons. So it goes 2, 3, 4, 5 onwards up to, and then it's obviously, as I forgot to mention before, it's hexadecimal, just like a MAC address is. So a huge number. So yeah, we're just going to go for the very first one, but we're not necessarily going to be, when we give in our IP addresses, which we'll get onto next, it's not like we're then going to give out .2 as our next one and .3, which is why I mentioned the DHCP not being as you think it is. So that's going to be our IP address of our LAN bridge. That's our interface, and we don't need to do anything else. We just need to make sure that advertise is ticked, which it is by default. As you can see, that's G for global. As I mentioned before, this is a global range because it starts with 2, so 2 or a 3. Global meaning public, so it's publicly routable. So now that I could, if I had another IPv6 network somewhere else on the other side of the internet, I could then actually ping this range or this IP address from the get-go. Notice we're not actually assigning anything to our interface Ether1. We don't need to give that an IP address, which is another thing you need to basically not unlearn, but think differently to IPv4. We just need to give it to our LAN. Because then if we then look at our routing table, IPv6 routes, see what I ticked when I got that prefix from the ISP, I ticked add default route. So here's our dynamic default route. This is actually pointing to, so FE80 is the link local address of our upstream ISP network, and it's basically reachable via Ether1. So the communication between router and between devices is actually done via its link local. Okay, so you're always going to use both. You're going to use the link local, and then you're going to use the globally assigned one, depending on what you're talking to. And as you can see dynamically here, we have every interface that it comes online will get its own link local address, and it's going to be based, normally it's based off the go to interfaces, bring up LAN 2 as its MAC address there. There we go. Where did that go? So 789A. So that's actually 7A, not 78, 9A, 18. So basically, yeah, part of it is random, and then part of it is often the MAC address split up, and then it adds this FE6C in the middle. So this is 66, the next one will be, and then 65, then 67. So basically, whatever the MAC address is here is going to use that. So that basically means that we get the subnets are so big that they can be broken in half, and you can then use the actual host component is made up of the whole MAC address itself. So, and the MAC address will always be unique for the interface. Okay, so that's why they do it that way. So like I mentioned before, we're not then going to be giving our hosts .1, .2, .3, .4. So we don't have to worry about that from a DHCP or from an interface. So sorry, device IP assignment point of view. So we've done our LAN range. We're giving it an IP address. Now we can look at our network discovery. Now, network discovery it's probably a bit misleading. It's basically the way that we're going to discover and assign and advertise IP addresses to our network. So this is basically what a DHCP server would normally be doing. So we say on our LAN interface, which is our LAN bridge, we're going to advertise our IP range, which is also doing based on our IPv6, isn't it? Based on our adding of this range here on the LAN side, on the LAN bridge, we're advertising that range out. Okay, so it's going to take that range and it's going to advertise it out to our network. Okay, if that makes sense. So we just need to select the interface, untick advertise MAC address. We want to advertise DNS and other configuration. Okay, that. There we go. So that's the prefixes that they're using to advertise out, and now that's a subnet of the one that we were given from the ISP. Okay, so now let's jump on our device and let's look at our, as I mentioned, 2 NICs. This is a USB one, which is just, as you see, another unidentified network, so there's no network internet access over this network. It's just the one that I'm accessing the machine through, but this is our main one. So we go status, and as you can see, IPv6, there we go, I've got internet on it already. Details, let's try and expand that a bit bigger. So we've got, I'll tell you what I'm going to do, I'm going to do it on command prompt, might be a bit easier. Okay, so ipconfig /all. Okay. So here is our Ethernet adapter. This is its MAC address. Okay. Now we've got, as you'll see, we've got an IPv6 address. Okay. Now we've also got a temporary. So these must have been old ones from when I first. Before I started the video, I just tested the config out. So yeah, so ignore those ones. So this temporary one, this is basically it's on Windows and it's on most OSs now. Because I've mentioned several times, these are publicly routable IP addresses. Now, if I'm going to be accessing something all the time from this machine, the end user, regardless if it's malicious or not, from the device that I'm accessing, it's going to see that IP address all the time. So what we do is, or what they do is, they give us this temporary one, which is again just randomly generated, but then but it's in this first, as you can see, there's that first range there. It's in the same subnet, and it's routable as much as this one is, but it's going to actually route to things like things over the internet, like websites, any sort of streaming stuff and stuff like that. It's going to use this range here, and then this one is the actual IPv6 address that it's got from the advertisement of the router. As you can see, my IPv4 is just a self-assigned one, meaning it can't get any network access, which is why it's not going to route on there. And the DNS servers, these will be the ones provided by the ISP. Okay, so it says we've got internet access. We can now go ahead and just test it out. Let's ping google.com. And there we go. I'm able to ping and resolve google.com to its IPv6 address. If you did have IPv4 on here as well and you wanted to check just the IPv6 one, you just do -6 google.com and it would do the same. Now, we've done all that and it's all working, but the key thing we need to do is the firewall. Now, I mentioned in many of my videos, the firewall is very important. You should, because the default, and I always advocate for removing the default configuration, it doesn't have anything in it. So we are now open, and not only is the router open to the internet, but my machine that I'm on right now is. So what we need to do is first of all sort out the input chain. Now, there's a few things we need to allow. First and foremost, because the input chain, we're going to block it on our upstream network, which is going to be our Ether1, which is our one facing the internet. We need to allow IPv6 DHCP requests or responses. So we're communicating with our ISP router, but we don't want to, by blocking everything coming in from that network, we don't want to then block our DHCP requests. So what we're going to do is we're just going to select protocol as UDP, and then destination port is 546. Coming in from that network, we're going to accept. Okay, that's our first one. And we always add our accepts before our denies. We want to, again, on our input chain, we're going to allow ICMP. So we'll go to, again, protocol. This time ICMPv6 is there. And then we're coming in from Ether1. And again, accept. Okay, now we can add our deny one, but we're going to do some other stuff rather than just, as well as just deny everything. So coming in with an Ether1, again, we're going to deny, but we're also going to anything that's not established, okay, or related. Because like if you've seen my other videos of IPv4, it's exactly the same. Stuff going out will become established. So we want to allow the return traffic to come back in again. Okay, an action, and then, sorry, by the ticking that exclamation mark, we're negating that. So we could just do that and have that as accept like that. But I like to just keep those rules all together. So we'll just negate that. So it makes this opposite. So anything coming in from Ether1 that isn't established and related, then we're going to drop. Okay. There we go. Okay. Now we can do our forward. So this is basically anything coming in from the internet. Now normally what we would do on the input chain is we'd be blocking anything destined for the router itself. But we want to now control stuff in the forward chain as well, because we're forwarding through one way and then we're coming in the other way. So again, we're going to go for our chain forward. We're coming out this time, going out of Ether1. We're not worried about this time about inter-LAN routing, because we've only got the one network. We're just worried about stuff going out to the internet. So anything outbound, basically we can just accept. And then before we add our drop rule for forward, the other thing we want to allow, in fact, we'll do it the same as we did with the drop rule. We'll do connection state, anything established or related that isn't established or related, we're going to then drop. So basically dropping everything except for those ones on the forward chain and going out of Ether1. Okay. So there's our very basic rules. There's a few more rules needed than IPv4 basic setup like I've shown before, but yeah, this should be enough to get yourself going and to protect you. We can see some connections happening already via my machine that I'm on, going to the public. As you can see, the connection states are established there. We can now just make sure that we've still got access after we added those rules. Okay. Good. So what we can do now is do some more testing, and I'll just show you some more gotchas with it, I guess. So as I mentioned, we've now got internet access via the IPv6. Now the reason why you couldn't just go ahead and set up IPv6 alone is because the rest of the world isn't adopting it probably as much as they should do. So for example, let's ping Google. Okay, Google gives us an IPv6 address. Let's ping the BBC. They give us an IPv6 address. Let's ping Amazon. Fairly big organization. Trying to resolve it to, there it goes, trying to resolve it on our, let's do it IPv6, because obviously it's still cached to an IPv4 address. There we go, could not find host. Okay, but if we ping my website, there we go, I've got IPv6 set up on mine. So this means that we're probably limited to what we can actually go to what we would normally go to. So as I mentioned, Google is pretty much, there we go, on board. We can go to Gmail, we can go to Maps. So pretty much most of Google's network is up and running. And as I mentioned, although we could ping the BBC, if we actually try to go to the BBC website, it doesn't actually, it may resolve the IP address, but it doesn't actually work from a web page point of view. Okay, and as I mentioned, although Amazon doesn't, if we try ping AWS.Amazon, they do. So AWS, if you're not familiar, is obviously Amazon's, I'm sure you've heard of AWS. If you're watching this video, you will have heard AWS is their cloud service. So that works. But now if I try and click on some stuff up here, there we go. It takes me to another URL, which obviously isn't reachable on IPv6. So we have internet access, we can access some stuff, but we won't be able to, you wouldn't be able to survive on IPv6 alone, which is where you would then need IPv4 and IPv6 running side by side. So the sort of people that would set this up are people like myself who want to do it because they're interested, who think that more people should be using IPv6, or people that, I can't ever see at the moment there's a need where you have to. So unless your ISP was charging you an extortionate amount of money for a public IP address and you had a particular service you needed to be able to reach remotely, you could then run IPv6 just for that. So you had a particular terminal server or web server or something you wanted to access and you couldn't do it on IPv4, then you would potentially do it over IPv6 only. But that would also require you to then have an IPv6 network somewhere else that you're accessing it from, unless we use what I mentioned before, that NAT64 feature. But we won't go into that here because we can't do that natively on MikroTik at the moment. So I think we've covered everything I want to. We can certainly get our access sorted. But the key things to think about, it's just really that getting your head around the fact that we don't put an IP address onto the WAN port, if you like, the internet port, like we would have done, because we're going to do routing everything using this link local. So my default gateway is the link local of the upstream network, and that's how we get to it. And it just basically tells you what interface to route out of, like you would do a tunnel maybe. Oh yes, that was the other thing I was going to show you. So if we go to my IP address, there we go. So that's my public IP. So normally what that would do is show you the WAN IP or internet service provider provided IP address on your router. And then if you did this on all your machines, all your devices in that same network, they would all have the same IP address. Now what this IP address is we scroll up to here. This is at that, as you can see, that temporary IP address. So we're accessing the internet, certainly web pages, using that IP address, not this IP address. Okay, so that one will periodically change. I don't know how often, but this one will stay the same, but then most of your routing will be done over this one. So you could route to both, but this one, like I mentioned, will eventually change to something else, so it will become no longer routable. And then that's just where the firewall is key to protect yourself from external access. So just imagine every device has your ISP is giving you a massive, very big IPv4 subnet, and you are literally going to configure an IP address on every single public IP address on every single device in your network. And in which case, when I access from this machine to the internet, I'm going to access it via my public IP address for this device itself, not the router one. So that's the kind of way to think about it. That DHCP server option, which is here, isn't really used to distribute IP addresses, but it can do other things like DHCP options. So if you've ever used options before, for things like a DNS server, NTP server. If you're deploying access points, you tell it where your wireless LAN controller is, things like that. That can be done here. That was the route, neighbor discovery. We're giving out advertised DNS to our clients. We are advertising the DNS that we are getting from our ISP. So we go use peer DNS there. So if we wanted to give out the Google's DNS, for example, we can go to Google IPv6 DNS server. There we go. So as it's still got the same, cleverly they used the same at the end. What we then do is, under this option here, paste that in, and then we can do the same for the secondary if we want. Okay, and now we're actually going to advertise those out. So if they're blank, we're going to advertise what the ISP is providing us. So we okay that, and then what we'll just do is do ipconfig renew .6. Okay, and that's just going to renew the IPv6 IP addresses. And now if we do an IP config all again, there we go, my DNS servers have changed. So we're now going to use 8.8.8.8, or sort of the equivalent of 8.8.8.8 and 8.8.4.4. But yeah, thanks for watching, and yeah, I'll see you on the next one. Cheers.